This is a presentation of SBE 15, New York City.
I'm going to start the first part of the presentation just talking about the company, our background, how we got started. We are a small family-run operation that creates widgets and gadgets to make radio studio installation easier. Michael is the engineer. He's the design guy. He takes the idea from the notebook through the design process, prototyping, all the way to the final product. I do everything from that point on. I take care of orders, shipping and receiving. I work with our manufacturer in China. I also just maintain the household because we've got 2 teenage kids that I know Michael put on here that our children, they do help with testing, packaging, and the assembly. And I love how we put the in whatever else mom tells them to do, because anyone who has teenagers knows that they do nothing that their parents say. For me personally, I like talking to engineers. One thing I love about broadcasting is that there's no one solution fits all. So I like talking to different entities, like, what's your studio like? What are you guys doing? What are you using? Because it's just a hodgepodge of everything. And it's just, everybody's always got a story. And I love that about broadcasting. We focus mainly in radio, but that doesn't mean that we wouldn't consider TV in the future. I have talked to some TV folks. It's just not right now necessarily in our wheelhouse too much, but things to think about for the future. One of the big questions we often get asked is, what the heck, why not a bot yet? And the answer has nothing to do with broadcasting whatsoever. This was our very first board. Michael was designing a robot with our youngest, and when he went to send the board to the board house, he jokingly put the little, it's not a bot yet, on the circuit board with our little Mobot logo. And then when he developed our first product, it was already out there, and it just sort of stuck. It's just fun, and it's just sort of stuck around. And this was that first product that started it all many years ago. I can't even say a few years ago, because this was probably 2014 or so, 2015. Michael was doing a studio project. One of his engineers, God bless them, spent days soldering 15-pin connectors, because we all know that engineers love soldering 15-pin connectors. After witnessing that, he just kind of decided that there had to be a better way. Spent some long nights designing a board with jumpers to just act as a plug and play, and use that board for his next studio project. Dave Kirsten, who I don't know if any of you have ever met Dave, Broadcaster General Store, great guy, was there at the project. He's like, hey, I could sell those. Do you think you can make more? And stupidly, we said, sure. So we made more, and things started to take off. We developed a philosophy for our company, which is really plug and play. Not that soldering doesn't have its place, but we really try to intentionally create products that make installations easier, are easy to install, because we just want to save engineers time. And word got out, engineers started looking at our stuff, orders started coming in. We actually now have dealers that cover most of the globe. I love the dogs and cats started living together. And we've learned a lot along the way. And Michael will talk about that a little later. It's been a great experience, and there have been many things that we have learned, good and bad, about growing a business. I'm going to just tap dance through our product line, talk about the breakout board for the Axia. We also have a version with relays, and that's just pretty much a simple pass-through plug and play. We also have an interface for the YellowTech Lit. It powers the device. You can see in the diagram, we try to design, again, plug and play, simple, strip the wires, plug them in, and away you go. All of our stuff is generally controlled through the Axia or WheatNet logic, because you're going to control all that with your software anyway. Okay, try to keep up, Michael. Oh
Sorry. Well, my my mouse went somewhere else.
Okay. We also have tally helpers. These are designed for the Yellowtech Mica mic arms. It gives you functionality of both the red and the white light feature. The main difference between the Tally Helper 100 and the 500, the 100 is designed for one mic arm. You can daisy chain it, or the Tally Helper 500 can do up to 5 mic tallies with individual control. Again, so many of our things rely on, it's going to depend on how you do your studio and what works best for you. We have some guys that like the 500 because they want to plug it all in one place. We have a lot that like to do the 100 because they can daisy chain it and it's a little easier to wire up.
Yeah, we want to offer that flexibility because different people have different building styles.
And we joke about how even a 12-year-old, and this is our daughter Tesla, who would probably kill us if she saw that picture because she's now like 17. But that's our video, is Tesla wiring up a tally helper
In real time.
Yeah. And shout out to Greg Dahl, because this is an example. Again, love talking to engineers because they come up sometimes with ideas that we're like, oh, yeah, we could do that. And
yeah, there was a conversation where Greg came up and he's like, hey, do you think you can? And then fill in the blank. And it's like, maybe we can.
Yeah. Our on-air 85, it's designed for an on-air light, just controls standard 12 volt. I can't speak for any of the old school on-air lights that may still be out there. But the beauty of this product is that it allows you to have different flashing, strobing light patterns, depending on if you've got phone calls, EAS, if you just want to leave it live because it's on air. It gives you that flexibility to play with your on-air light and have those options. Again, all of our stuff is plug and play with Axia or WheatNet logic ports. And the M Mount Pro kind of came out of the social media. Never did I ever think that audio would become video for radio, but it has. So this fits right in a Yellowtech Mica, right in the pole slot. You can put a camera on it. We have had some install small speakers because it's a standard 1/4-20 mount on it. It's fully articulated, kind of set it and forget it, except we all know that staff never actually set anything because they're constantly playing with stuff. Our Studio Jam it's a studio lighting kit. We provide LED strips, all controllable. We do utilize a Cat 5 from controller to strip. For this one, a lot of people are like, oh, can I just buy something on Amazon? I'm like, you can, or you could buy ours where you can actually, like, again, plug and play and control it through your Axia or WheatNet and have it do. The example here has got it on the wall. We see it a lot under tables, in table legs. It's just a really fun little add-on. And if you would ever need more lights beyond what's provided here, we do have what's called the expansion jam. It just plugs into this system and gives you more lights for however far you need to stretch it.
Can you give us an example of how you would use this in a studio? Like, is this used for on air, or just different shows would have different lighting schemes?
Yeah, you could do that. So for instance, when we did the very first one of these went into the Mancow studio in Chicago back when he was in Chicago. And so we had engraved in the legs and the furniture his head, because it's Mancow. And so what we had was, if it just kind of did a standard color changing, but as soon as you turned on the microphone, they all went red. And if the phone rang, they would like flash strobe, they would like strobe white flashing. So it was just kind of a cool thing. And in the photo you see here, we added some accent lights along the back wall, in the sign and the legs. And the operator had like one of those little button panels from Axia, and they could just choosing that, they could scroll through all the built-in presets. So you don't have to worry about like that little, remote control or anything like that. But yeah, it could be driven by the microphones. It could be driven by other events. You can, Pathfinder is what we use to control it in an Axie environment. In WheatNet, you could control it with with their scripting engine. So just gives you flexibility. That's what it's about. The other novelty of this one is the Cat5 adapters, the Cat5 to LED strip adapters. That was the thing we found. It's like you got to solder all these little connectors or use these little pin connectors that never stay connected. So we came up with a strip adapter that clips onto the strip. You just cut the strip and clip it on. And then you could use a Cat5 and extend that 5, 10, 15 feet wherever you need to go. And so then it plugs into the back of our controller, which is all Cat5.
All right. And that's, I'm waiting for, there we go.
Sorry, I'm slow in the draw.
Oh my gosh. Obviously you can go to our website, look at all of our products. We have the wire diagrams, installation examples, and I've touched on all of our products except one, and that's the Howler Monkey headphone amp. And that's because Michael is going to walk through the love affair in creating that particular product. And that's where so I'm going to hand it off to him to talk about how you go from a concept through the design, through manufacturing to final product.
Yeah, that's one way to put it. Love affair. So again, I'm going to apologize for my voice. I hope it's not too distracting. But first of all, it's like we're going to talk about how to develop a product. And I know they say, don't read bullet points from the slides. Well, this slide, I'm going to read the bullet points because it's strictly for effect. Because to develop a product, you need to determine the need, study the competition, do your homework, design in sections, prototype again, repeat as needed, test and document. Don't forget the mechanical engineering, determine what it's going to have to sell for to be profitable, pre-production prototypes. Yep, that's the one, really, maybe, hopefully. First production run, insert panic here, write the documentation, develop the packaging, write the product web page, and then freak out a little. So there you go. That's the whole presentation. No. All right, so we'll go over some of these in a little bit more detail. I'm going to try to use a real world example, the Howler Monkey. I'm going to try to, this is more technical. I'm not trying to pitch, sales pitch the Howler Monkey. However, buy as many as you want because I think they're awesome. It was full of ups and downs during its release. I still feel it's our best work to date, but it was a real pain to get there. And by the way, it was released in Q1 of 2020. So, yep, that happened. So let's make some sausage. First of all, how to not develop a product. So at NAB, Theresa gets this a lot. How many times have we heard, oh, I could build that myself. Oh, my engineer could build something like that. And you can, absolutely. And you're probably going to end up with something like that. Okay, well, that's not really a good example. That's the Apple One, and it kind of worked out okay for those guys. So maybe something more like this. The ubiquitous Radio Shack perf board. And by the way, I love seeing stuff like this. We were talking earlier about before the call about Tim Wright and some of his presentations on building little problem solvers. And I love that kind of radio engineering, and it's great, and there's still a place for it. But not everybody has the time to do that. Contract engineers who are trying to take care of a whole bunch of stations need to get in, get the job done, and move on. And so we're hoping that some of our products can make that better. But you have to design them so that can happen. Because building a manufacturable product, it's not like building that one-off problem solver. There's a lot that goes into it. So obviously we talked about, you got to determine the need. Is this something that's needed? Is it viable? There's a lot of problems that I see out there that I'm like, oh, I could build something and solve that. But would it be worth it? The time invested, maybe I'm solving a problem that doesn't really need to be solved, or maybe it's just not that big of a problem. So can you do it economically? Can I make something that people would buy because there's value? If they can buy it, it's going to save them time. Maybe not. And of course, the question that Theresa asks me all the time, how many can you sell? So study the competition. Anyone that says they don't care about what the competition is doing is either a fool or a liar, because you have to know what's going on in the market. You have to know what's around you. We study our competition. We're friends with our competition. That's even better, because this is a very small community broadcasting, and you just don't want to make anyone angry. So you don't want to copy the competition, but if there's something that they're making, can you make it better? Can you make yours stand out? You just don't want to make a cheaper version. So for instance, we get asked all the time, hey, would you make like a Matchbox? Hey, would you make like a low level to balance converter? Can you do this? And the answer is, yeah, I could do that all day long. I could do that in my sleep. But why? Hank makes a fantastic box, and there's absolutely no reason to try to copy it. Could I make one better? Probably, but it would probably cost more than people want to pay. Hank's is like that perfect, match there. I don't think we can add any real value to that. Now, that doesn't mean you can't steal good ideas. We've, seen a few good ideas and stolen them, but you don't just want to make a copy. Plus, there's so many other people that have tried to copy Hank's box. And frankly, if I'm buying one, I'm buying a Matchbox. That's just the way it is. It's not an endorsement. He didn't pay me. We didn't talk beforehand. Do your homework, research. Research is boring. It's not super rewarding until you find that diamond in the rough. It is time consuming. It's also necessary because that's how you find the part that you need to do the job. Also, not just research of looking at data sheets. You look at certain example circuits, and they don't have to be new ones. The Howler Monkey uses this Baxendall circuit for the volume control that was published in the 1980s. And why do we use it? Because it friggin' works, and it's great, and it's very straightforward, and it solved a problem that we had. Also, undo your homework, test the devices. We went through a lot of different final amps testing it. And of course, they're all surface mount. And of course, they're all tiny surface mount. So that's fun, but thank God for little dip adapters so that you can test these when you're breadboarding. But we probably went through at least 7 final amplifiers. And, just as karma would have it, we picked the one that was the most unstable if you provided poor power. It required a very specific PCB layout. It could oscillate uncontrollably if you had the wrong gain selection on it. But it was also the one that sounded the most awesome, and I just knew we had to have it. And Theresa just rolls her eyes at me all the time. It's like, why are you buying more chips? I'm like, because those didn't work. I got to find something else.
It became like an eye test, but for your ears. Which sounds better, this one or this one? I think this one sounds better. The pain.
Yeah. Design in sections. So like for the Howler Monkey, we broke up the design in 5 sections: line receiver, volume control, power amplifier, and of course the glue circuits, anything left to put it all together. Just breaking down that design makes it a little bit easier to go. So for instance, the line receiver, we had some requirements. We wanted a very high common mode rejection ratio. I didn't feel like laser trimming my own resistors, even if I could. So that really leads us to like some of the single IC solutions. We chose one from Burr Brown. I could have gotten pin for pin compatible ones from that semiconductor, Analog Devices. AKM is what Axia and Wheatnet and a lot of the guys out there use. AKM is also the plant that burnt down. But it's just, you find the device that you think is going to fit the bill most, and then that's what you design around. Power supply was a little trickier because my requirements was I wanted just a basic 12-volt DC input. I hated, I wanted to make sure this was a full double-ended supply, not a single-ended inside. I wanted a full plus and minus 15 on the inside. I always hated seeing these little special power adapters that had, they're either AC or they got plus and minus on them. I just wanted something you could grab off the shelf that probably was hanging in the parts bin if something goes bad. So that means switch mode inverters. Yep, in an audio device. Don't shoot me, but this is how we got the plus and minus 15 volts. And actually, the chip we used you could actually put as small as 5 volts in this and still get full power out. I actually ran it on a USB port from a computer just to power it, just for testing. I don't recommend it. We recommend the full 12 volts, but again, flexibility. The volume control, I mentioned earlier, the Baxendale circuit. We chose this because it allows us to use a linear potentiometer and give a logarithmic volume response. If you ever try to find a good logarithmic potentiometer, they all suck. That's just a known fact. They all suck. They're more expensive and they're hard to find. So linear potentiometers we can get all day. So use the Baxendale circuit, we can get a logarithmic response. And of course, in that circuit, we use the OPA 2134s. We could have just thrown in a cheap 5532, but again, in the words of John Hammond of Jurassic Park, spare no expense. We actually built a version with a 5532 and built a version with a 2134, and there was a noticeable difference. And Theresa will tell you she's got an untrained ear. I always use kind of her as the test to make sure I'm not reading something in there. And I'm like, okay, blind test here, A and B, A and B. And she's like, oh, this one's better. And then she looks at me, he's like, that's the most expensive one, isn't it? I'm like, yeah, of course it is. Of course it is. Yeah. But that just tells me that if she can hear the difference, then I know that guys like us that do this all day long can hear the difference. Now you got to put it all together. We did our first prototype run. A lot of board houses there have this 10 PCB run. To make my life a little more sane, we did through hole for all the passives. And actually, like our early production run, we did through hole for that. Sometimes you'll want a second prototype. I mean, always you'll want a second prototype. Here we kind of changed the power structure, the way the audio loops through the device, because you can daisy chain the power on these. And that was a recommendation from a friend after I was talking to it with a peer. They came up with that recommendation. I'm like, that's a really good one. So a little tip here: always listen to other points of view. And I said we made that 5532 version. You're actually looking at it. This is actually a photo of that particular version. Luckily, the chips are pin for pin compatible, so it's pretty easy to test one and the other, and everything else is the same. The third prototype, all surface mount, except the connectors. I'm just a snob. I don't like surface mount connectors. I like them through hole to give just a little bit more physical connection to the board. Hand soldering surface mount, good times. But I kept everything like 0803 or larger, so that I would be sane at the end of the day. And this actually was pretty much the design that we based the first Chinese production run on. And of course, before you can send it to China for manufacturing, you have to make changes. So I can come up with a board and it's great and I'm happy with it. And it's like, now I got to modify it for manufacturing. So you have to add these little wings here so it can go through the slots of the automated soldering machines. And then you have to add these little V grooves, little slots, so that those can break away. You have to add these little fiducials around here. They look like vias, but they're not. They're actually little dots that the camera systems in the pick and place machines use so that they know how to put and orient. And so across the board from one side to the other, I could put them in the corners, and that's pretty good. But the more fiducials you have, the camera system calibrates itself as it's moving across and just gives you the most accuracy. Again, probably not as big a deal for 0803 size components if you get down to some of the really tiny stuff like you see in iPads. Document, and test. After the first prototype was built, test it, adjust, redesign as needed, create a methodology for testing so you can get the repeatable results. And just a little advice, make sure your test load can handle the power. So this is a headphone amp, and I'm like, okay, I've got these 33 ohm half watt resistors. That should work. So I run up to, the max rail at the point of clipping, just to make sure that everything is driving the load okay. And I turn away and I look back and I started to smell something, and there's a little smoke coming out of the 33 ohm resistor. So I shut it off and then did a quick calculation. It's like, okay, I'm putting 1.5 watts RMS into that 33 ohm load. That's a bit more than a half watt resistor can handle. So important safety tip, don't burn down the house when you're trying to design something. Of course, if performance isn't expected, determine why and correct. Not going to mention who, but this is just one of those old cheap $100 headphone amps. We did a similar test. You can see like ours, this initial test, we started to roll off there on the bottom end, but we were getting about 17.4 volts peak to peak. And the competitor there was getting about 5.12. And their output final was really like what you'd find in an iPad or an iPod or some sort of small portable electronic device, really just designed to run the little bitty headphones. Oh yeah, mechanical engineering. Yeah. It's great when you're in electrical engineering, you can design this stuff and then you have to learn to do mechanical engineering. But luckily, as I'm sure our fellow electrical engineer on the call will attest to, we're overqualified for mechanical engineering. So yeah, so you have to determine how's it going to mount, what kind of case, hopefully not like a little Radio Shack. Who's going to design it? Yep, probably you if you're a small business. And of course, doing the electrical engineering and the software engineering and the mechanical engineering. Now I'm Tony frickin' Stark. So I guess I got to design a suit now. Review the do your homework section. You gotta research. Learning to use 3D CAD programs. I've used parametric CAD programs, but this was my first foray into designing a sheet metal case for a product. So that was new and interesting. Thank God for the internet. But yeah, you have to design something that's really appropriate. You got to think about where your mounting holes are, your controls, your connections. And back to that thing I talked about on the PC board, it's got to be manufacturable. Sheet metal of different sizes have different bend radii. You have to put in bend reliefs if you need flush bends. You have to put in PC mounting bosses if you want your PCB to actually mount in there. And then of course tolerances. As you fold these and put them together, what's going to be the tolerance of how it fits. There's always going to be too tight and too loose. So how do you make sure that the tolerances keep it in the middle where you still have a good product at the end of the day and it's manufacturable? The higher the higher the tolerances, the more you're going to spend.
Thank God for 3D printing, which is
yeah, absolutely. So, and that's what we do. So 3D printing, prototyping the case, a cheap way to verify the measurements and make sure everything fits. So we actually printed a case from the model from Fusion 360, and we're able to build up the entire thing. And it's crazy because that's the first time you see it all together as one product. Yeah, I know it's a paper labeled with the silkscreen, but it's a product, and it's like you just have this big smile. But it helps you test the look and feel, verify that the PCB is going to fit, verify that you can put the PCB in and out. Even with our design, you still have to kind of go a little kind of a crazy angle to get it in and make everything fit. But this allows you to fix issues before committing. And, if you screw it up, it's only a few grams of printer filament. So this was probably the third or fourth one that we actually printed. And I actually cheat. I've got a picture down here. I do a couple of different things. I'll take an old PC board and I will print out on a sticker the new layout, and I will drill the holes and mount components and just test that. But I also will actually just 3D print a circuit board in plastic and draw out the holes and put the components and test that fit before I send it to the board house. So just all kinds of ways to just test the look and feel of the mechanical engineering. Oh yeah, and silk screening. So now we can add graphic design to our skill set. You have to export to 2D projections, get everything sized right, and design a silkscreen. And the Howler Monkey logo, I actually designed myself. I took a picture of a howler monkey and traced it, and then kind of turned it into a cartoon and put headphones on it, and it became a howler monkey. And then we have to import, you import that into vector art software, export all that to DXF, and that's what the silk screeners need. Our serial numbers, we actually laser etch them because we use a thick powder coat. So we just laser etch the serial numbers just to give a little extra flair. So all these design decisions still in the mechanical engineering, steel, aluminum, brushed, powder coat, about 5 million other decisions. The picture here is of one card of about 4 or 5 of different powder coat finishes and types. So you can see there's all the different colors. And then the other card on there is like the finishes: hammered, smooth, textured, glossy, rough. And you have to choose all of that. And the reason you have to is because whatever you choose now is what everything down the line is going to be made from. We actually had a couple of runs where the powder coat wasn't the same, and we had to actually work with the manufacturer to make sure that there was consistency. What will it sell for? So you're at the point now where you're on the cusp of manufacturing. Now you have to determine, can you manufacture it and sell it at a price that you can still make a little money and make a profit? And you have to factor. So now let's add accounting to that list of skill set. But you have to think about all the little stuff, not just the cost of the components and how much to make it. It's like shipping. Let's not forget the tariffs, labor to assemble. Even if we're assembling it in-house, we may not always do that. We might outsource it at some point. So you have to have a budget in there for labor to assemble it, because your time is worth something. And at some point you may have to have other people do that. All the accessories, power supply, screws, packaging. And then after you figure that out, how much money do you want to make on each unit? Oh, and let's not forget the dealers want to make money as well, and your distributors. And then a little bit of an allowance for shrinkage, returns, defectives. Typically that's about 3% average. So you throw that in there, and eventually you come up with we have this spreadsheet formula where we have all of this in there. We put in the costs of everything, and it basically tells us what it should sell for. And that helps us to make quick decisions on whether or not we're ready to move forward with something. Now you're ready to do that pre-production prototype. This is where you make in the first one. Our manufacturer, like our cases, they did like a sample of 3 circuit boards. We would commit to an order, but they would send us about 2 or 3 to test and verify and make sure that they work before they do the full production run. So once you've done that pre-production prototype, now you have a decision. Do you send the entire thing to China to manufacture, which is a crazy choice, or you do the first 100 units in-house? Which do you think that we did? So yeah, while we were working on that Chinese version, we actually did a pre-production run of about 100 units using the through-hole design, and we did all that in-house. And when you make a small change, well, I'll talk about that later. So you're ready for manufacturing. You determine whether you're going to manufacture in China, the US, no matter what, just find somebody that's reputable, reliable. We got very lucky in our Chinese manufacturing because we actually found a service through the maker community, specializes in low and medium volumes, 100 to a couple thousand, rather than a million like Foxconn and some of the guys making iPads. We've been lucky enough to work with the same contact over there for like 7+ years, and they were great at resolving issues. So now the issues, even with a good manufacturer, you can have issues. So again, I talked about the samples. Our first sample, the silk screen, was terrible. You can see it was kind of blurry. It wasn't working. And it turned out that just there was a certain tolerance that we needed to have on the files and the separations. So we had to actually give them a new file, and then they did a new sample and sent us photos. So the first 100 units we did in-house, we did have the cases made in China. The PCBs are always made in China, just the blanks, but then we assembled them in-house. And then that was a mixture of surface mount and through hole. That was a labor of love. And of course, after you get them all assembled and put them together, you find out that there's an error on the actual board. Rather than just building one and testing it, you build them all and then you decide to test. So don't do that. There was a slight adjustment made to make it fit the case, and that kind of dragged a trace in the PCB software along, and it went unnoticed. And then we also found out, in addition, the left and the right were reversed on the 1/4-inch jack because of a bad template in our PCB design software. So the very first 100 units, they shipped with bodge wires, because when you've invested that many thousands of dollars and you're a small business, you've got to get it out the door. Everything was fully warranted. We've only had one of those ever come back, and it was just a bad capacitor. But again, after we built those 100, we sat on them for nearly half a year before things started to loosen up later in 2020. Here's where it gets worse. So then we spent 2020 kind of moving that manufacturing to China. The first 100 units, 70% failure rate.
I cried. I
Wow.
just cried.
It was a bad day in the NotaBotYet household. It was most of the issues were faulty ICs. You can see this. I took a close up. Some of them actually had physical cracks in them. We don't know if they were counterfeit. We don't know if they were recycled off other boards. We don't know exactly what happens. And our manufacturer, they're more of a rep, so they're sourcing the parts from different places, and it's not uncommon for counterfeits to get in even to a good supply chain, even with reputable dealers. So they were very good. They sent replacements right away. They sent some. They're like, here, test these. If they work, we'll send you more. And they did. No questions asked. But it's time. We had to make all these repairs in-house. There was just, again, too much investment on the line to abandon the run. We had to make these work. And so, yeah, a lot of hot air reflow was done that day. A lot of testing and burn in. Lessons learned the hard way. But then the second 100 units, 30% failure rate. More faulty ICs. Some shipping damage. I show pictures here. Some of them had shipping damage. So again, we worked with our rep over there. They made sure that everything is packaged well. Things come packaged very well now from them. So it's just sometimes it's really about communication. The thing that we've learned working with our Chinese counterparts is China will make a lot of decisions for you if you don't tell them what needs to be done, and they will try to do it economically because they want to save you money. They want to be, they want to be good. They think that's helpful. Doesn't always work out. So we've established a really good relationship with our Chinese contact, and we're able to resolve these quickly. Then we kind of get down to this next batch, had about 10%. Not as many IC problems. We think we finally solved that. They changed their supply chain on their end. But at this time, we started getting units back from the field, and that's when it gets scary. It's like, oh my God, what have we done? We've got 300 or 400 of these out here, and what's going on? We started to do 48-hour burn-in tests on all units before they go out. That gave us an additional 5% of failures on units. It took forever. And then you find out, remember when I said that the Chinese will do you a favor? Apparently the voltage specification for these 7 capacitors in the power supply section, we did not specify a voltage. So China, gladly, being very helpful, supplied 10-volt capacitors, so that that was a good cost and savings, and yeah, they probably should have been at least 25-volt minimum. I spec'd 50 volts. We updated the BOM for all future production runs. The thing is, even a 10-volt and a 50-volt in that size capacitor, they all look exactly the same. There's no way to tell one way or the other. We increased our warranty period on all units below serial number 500. We've resolved the issues. Of the last 400 units from China, I think we've had 1 defective potentiometer, 1 defective IC, and a couple of cold solder joints. So kind of more along the typical lines of a failure rate that you would expect off the shelf. We test all the units for audio. We listen to the audio, make sure it's quality audio, and we burn them in for 48 hours before packaging. We really take this stuff seriously. And, I'm sharing this publicly. I mean, we tell people all the time, but we share it publicly. We want to be fully transparent. Running a business, developing a product is hard, but we want our customers to know we take this very seriously, and we really care about this product and care about audio and care about the customers. And that brings us to the documentation. So now we can add technical writer to the list of skills after, what are we, accountant, and mechanical engineer, electrical engineer, troubleshooter, chip repair guy. I'm not going to go into this a whole lot, but you got to tell the product story, lots of photos, lots of hookup diagrams, show it to someone who knows nothing about the product, and ask what question and see what questions they would ask. That kind of helps you, because when you're very familiar with a product, it's very easy to just make certain assumptions. So you have to write documentation without those assumptions. And that's why it's always nice to bounce it off someone who has no idea what the product is or what it does, and see what questions they ask. Packaging matters, and especially matters to me. I was once on a project, I received 60 headphone amps from a competitor on a project. They were literally thrown in a box. There was like a box that was probably maybe 15 by 15. There was a layer of amps, and there's a bubble wrap, a layer of amps, bubble wrap, a layer of amps, bubble wrap, a layer of amps, bubble wrap, all the manuals for all the amps, and then a layer of bubble wrap, and then all the power supplies for all the amps. It's like there's no box, no packaging. The amps were not wrapped in plastic, nothing. We don't have to be fancy. I mean, we like to be fancy, but we just use off-the-shelf white shipping boxes. They're very inexpensive. They all ends up in recycling anyway. The label's just a laser label. We do add a little velvet bag just to kind of give that little extra, ooh, pretty. And of course, everybody likes those because they use them for screwdrivers, tools. I've had a guy thank me. He's like, "Hey, I got another tool bag for my little collection." Just like we all use those cases for the EV microphones. So, and of course the product web page. So now you can add webmaster to that list of skills. Tell the product story, lots of photos, blah, blah, blah. Show some, yeah, that's a copy of the instruction slide because it's pretty much the same thing. You want to make sure that you have all that information out there for people to find. Make sure they can find the instructions, but be efficient. And, remember, the first time you do something is the way you're going to continue to do it. So be consistent. So try to make sure that your website documentation looks the same way as your regular documentation. So in summary, because I know I've talked a lot, my voice is terrible. I've probably bored you to death. But in summary, yes, Thresa is awesome. I have to say that. I'm legally obligated. NotaBotYet products, actually they're better and they're good, they're great, but I am biased. Designing products is hard. Manufacturing products is even harder. Learn from mistakes, make the next version better. But the big thing, take care of your customers, even if it costs you. We've had customers call us like, "Hey, I had this power supply went bad," or "Hey, this doesn't work." And we're like, "Let us just send you a replacement. Send it to us, we'll look at it, but take the replacement." And of course, most importantly, convince your wife you need at least one more prototype. So that is hopefully everything. I'm sure I probably could have talked a million minutes more, but I think that covers the bulk of it.
Well, I found that fascinating. I've never seen any presentation like that before. I do have a question, but before that, I want to ask you, is this the first time you've done this presentation?
This is the very first time we've done this
I
presentation.
think
We wrote this presentation just for you guys.
I think you can present this to a lot of other folks,
Very nice.
SBEs. Yeah, I think they would benefit from it. So I just installed a whole bunch of NotaBot stuff last week, as Michael knows. So it was kind of my introduction to it. But my question is for anybody on this call or anyone watching this recorded, because this will be on our website, is if there's anybody who's watching this and has something they want to start their own business, or they have something they think is out there that would be great for helpful to broadcast people or anything else, what would be your one piece of advice? There was a lot of material you just went through, but one piece of advice.
Oh,
Both
Go
of you
ahead. Yeah, Thresa, go.
no, I would say that coming up with an idea is always the easiest part. That is always like, "Ooh, I have an idea." Michael will tell you, I'm a finisher. I'm all about the fine details, because whatever you do the first time is how you're going to do it every time. Put in the work on the front end, because we spend a lot of time really thinking of the end user. Because if you put all the work on the front end before anything ever leaves your desk, your house, wherever, then you will have less problems on the back end for all the things that it will save you redesigns. That's why we prototype so much, and Michael jokes about it, but nothing is ever done right on the first board. So just really spend a lot of time thinking, let it set, come back to it and rethink, can I design it just a hair better? Can I do this just a little bit better? because once it's out the door and gone, making changes is really hard.
So for me, besides specify your capacitor voltages ahead of time, my best advice would be to know your why, know why you're doing it. And that I didn't come up with that. So Lady Ada of Adafruit there in New York City actually on their website did an article kind of about starting a business, and one of the things was know your why, understand why you're doing this. If you're doing it for money, this maybe not the thing for you. But if you're doing it because you kind of feel like you have a purpose, follow that. And I encourage people to look up that article on the Adafruit website, because it's really good, especially if you're thinking about starting a business and you have a product idea.
As another person who has their own business, I think you guys would agree with me. It was a lot harder than I ever expected it to be. But the best is when you come up with an idea and then you see a finished product and it's like, oh,
Yeah, it's very rewarding when, like I said, when you've got like that Howler Monkey, or even our very first product, the little breakout board. When you get your first big shipment from China and there's like all there, it's like Christmas. It's like, wow, we made this. It's awesome. Uh, absolutely.
it's amazing. Let's open the floor for anyone else who has questions. We'll go to William. He's got his hand up.
Hey, hi. Can you guys hear me all right?
Yeah, I hear you fine. We'll come back to Keith in a second.
Oh, okay. So I don't know where the Howler Monkey name came from. It came in a little late. Could you tell me a little bit about where the logo came from?
William, I'll jump in. So, and Theresa will tell you, we probably went through about 50 different product names. Just because, this was a big enough product. We like names that are memorable. It's like, if I told you, hey, go buy the HP 100-0-5, that's major boring crap. So we wanted something that was interesting. And I was researching, I'm like, okay, what are the loudest animals on Earth? And there's like a list, and Howler Monkey is in the top 10, and it just rolled off and sounded fun. I'm like, Howler Monkey, it's fun to say. And it is one of the loudest animals on Earth. And one of the things we try to, on our amp was we wanted to note that it's very loud compared to some of the other headphone amps out there. And so that the name Howler Monkey was born. And as far as the logo, I talked about it a little bit earlier. I actually found a picture of a Howler Monkey online, brought it into a drawing software, traced it and turned it into a cartoon, added some big cartoon eyes to it, and they added headphones to it. And I'm like, that's it. That's the one.
I think that's really great. During your presentation, I looked up Howler Monkey and I found a Wikipedia page. And so it's really great, because then you guys have this coincidence with this Wikipedia page, and then we all get to learn about, what's going on in nature. Hey, that's something we should know about. We're even electrical engineers, but we should know more about nature, right? So that's really a cool name.
Things you need to be an expert on too. We'll go over to Bernice now.
Yes, actually, I've heard and seen Howler monkeys, and they sound like a train. And I'm not deaf. I actually just was wondering, first of all, if you'd make your slides available, or I'll go watch it again, which I'm already looking forward to. I think my question and I feel you on the mechanical engineering, because that's what stopped me, is the drilling through metal boxes, and the grounding problems I've had with my guitar pedals. I think my question is, like, how big an investment? Where do the startup money? That's also something that stops me cold. That sounds crazy. Didn't you have to get that?
It can be daunting unless you, again, do the mechanical engineering yourself. Because if you have to pay someone else to do the mechanical engineering, you're looking at several $1,000s. I can see Theresa wants to say something too.
No, I in terms of initial investment, it can be. I always tell Michael I'm a cheap date, because I am all about how can I put in the legwork? Michael, into his credit, has spent a lot of time for the Howler Monkey learning a lot of software he wasn't familiar with. Designing the case was completely not in his wheelhouse. But because I don't want to go and spend thousands of dollars hiring a mechanical engineer, and honestly, I'd rather keep it all in-house. I'm that way. It can take a little more, I don't want to say time is money, but that's really what it is. I'm saving money by investing Michael's time to learn some of the skills that might be out of his comfort zone. And for us, one of the biggest benefits is that because we don't do tens of thousands of anything at a time, well, not right now, at least maybe, working within a smaller entity with our person in China, we can do those small batches that aren't going to bleed us dry financially.
Yeah, and I'll in full disclosure, I'll share. So to get those samples of the cases, after we sent the design and did some back and forth, the samples cost us about $500 to $700. So not out of the park, but they're much cheaper in quantity, obviously. But yeah, it wasn't thousands. So that's the big thing. And again, working with places that are designed for smaller startups. Same thing on the circuit board stuff. Basically, we make the initial investment of like a run of 100, and it's materials and labor and everything to assemble that. So that that works out. Again, we're probably paying more than if we had several thousand made at a time, but you can mitigate that initial risk. And if you want to reach out, I'm happy to talk to you offline about it too, and give you more details.
One other question before I let someone else. Do you have a machine shop, or do you use a makerspace?
The makerspaces by us are just a bit too far. I don't have a full machine shop, but I do have a drill. So no, I could do minor machining, but I don't have a lathe or a mill or anything like that.
Okay, thank you. Yeah,
but I have 3D print. We have 3D printing.
I was going to ask you about the 3D printer.
Oh, we have two. We have a couple.
I think we're going to wrap it up now. So we'll have a copy of this on our website. I know some folks have joined later and missed some of it, and also tell your friends. Yet again, I find this fascinating. I've never seen a presentation at an SBE meeting quite like this. And I'd like to thank everybody who joined us. Also, if anybody on this call is going to be out at the NAB, I believe you guys will be there yet again, and so will I in the Broadcasters General Store booth. I know it's a little early, but I think if there's anything new and exciting, or even if you want to see the Howler Monkey in person, plus collect your monkeys, your plastic monkeys to shoot at each other, which I got mine. Be sure to stop by the Broadcasters General Store booth at NAB, and you can say hi to these folks in person. Thanks again. I'm speaking for everybody here. Really appreciate your time and the presentation and putting that together, especially for us. Conrad, anything else to say before we?
No, presentation was superb.
Jeff,
appreciate it. Yep.
Could we get Keith's question in?
Yeah, Keith's back. If
Keith?
You want to try
yeah,
that.
real briefly, I'll take a second. It was a terrific presentation. Having been involved with some family manufacturing, I could see some of those horror stories, but I think it was partially answered. I was just curious, do you do any custom work, or do things come across your desk where people approach you?
We get asked occasionally, hey, can you make this? And the thing is, I do have a day job. My boss is really tough to work for and very demanding. So I don't have a whole lot of time to do that kind of stuff. And then my other boss is very tough too. So I don't have a whole lot of time.
Don't forget the two younger bosses also in the same house who are much more demanding than I am.
Yeah, two teenage girls. So, but
Got it.
yeah, so one-off stuff. We don't really do a whole lot of that. But when people come to us with product ideas, we definitely think about them and evaluate them and see if there's any there. Absolutely.
Very good. Good. Thank you. And thank you for giving me another shot at it, Conrad.
So everybody have a good night. Stay safe. Happy Thanksgiving, and we'll see you next time.
Thanks for joining us. Please remember to subscribe to SBE 15 New York City